Hello friends, let us study one of the continuous probability distributions, that is exponential distribution, and derive the mean of an exponential distribution function. The exponential distribution function is defined as f of x is equal to alpha e raised to minus alpha x for x greater than 0 and 0 for all other values, and here alpha is greater than 0. Now we can see that x is greater than 0 as well as alpha is greater than 0. That implies this function alpha e raised to minus alpha x is always greater than 0, and for all other values it is 0 only. Hence in all we can say that function f of x is always greater than 0. And if you consider the other condition, that is integration from minus infinity to plus infinity of f of x dx, will take integration from 0 to infinity, because for an exponential function x is always greater than 0. So instead of minus infinity to plus infinity, we will take integration from 0 to infinity f of x, that is alpha e raised to minus alpha x dx. Now keeping alpha outside, integration of e raised to minus alpha x gives e raised to minus alpha x upon minus alpha. The limits are here from 0 to infinity. Alpha gets cancelled. We are remained with minus sign, and if you put upper limit infinity, it is e raised to minus infinity. Lower limit is 0 minus e raised to it is 0. Now e power minus infinity, we know that it is 0, and e power 0 is 1. So integration from minus infinity to plus infinity of f of x dx, we got it as 1. Hence we can say that this distribution function satisfies both the conditions, that is f of x each probability is greater than or equal to 0, and sum of all the probabilities is equal to 1. Hence the exponential function can be treated as a continuous probability function. Now let us see the way mean of a exponential distribution. We know that mean mu is integration from minus infinity to plus infinity x into f of x dx. For any continuous distribution, this is the formula for mean: integration from minus infinity to plus infinity x into f of x. Now we are deriving the mean of an exponential distribution. So we will substitute the exponential distribution function for f of x, that is alpha e raised to minus alpha x. Now here alpha is a constant, we'll keep it outside, and for a exponential distribution we know that x is always greater than 0. So instead of minus infinity to plus infinity, we'll take the limits from 0 to infinity x e raised to minus alpha x dx. Now alpha as it is, x here as it is, that is we'll go for integrating these two product of two terms by the Bernoulli's rule. X as it is, integration of e raised to minus alpha x, it is e raised to minus alpha x divided by minus alpha minus derivative of x, which is 1, integration of this integrated term again, it is e raised to minus alpha x divided by minus alpha whole square. Now the limits are from 0 to infinity here. Now we get minus x by alpha into e raised to minus alpha x, minus alpha square is plus, so it is minus e raised to minus alpha x by alpha square. Limits are from 0 to infinity. Substituting upper limit in both the terms, we will get 0, and substituting lower limit, first term becomes 0. So what we are remained with is only 1 divided by alpha square. 0 because upper limit will make all the terms 0, minus lower limit. In the when we substituted lower limit here, first term again becomes 0, minus we are remained with 1 by alpha square. Now 1 alpha cancels, minus of minus we get it as mu is 1 by alpha.